Part 1.
Now, remember that we say that let alpha and beta be the roots of given equation. So let alpha and beta be the root of given what? Equation. And at that, we go like this. Imagine we are having something like this. Having into bracket x minus alpha, then x minus beta, make it equal to 0. This is how it started. So now we want to expand this equation. So we are expanding the bracket. Now expanding the bracket, we go like this, x into the whole of this, which is x minus beta. Then we are having minus alpha into x minus what? Beta equals to 0. Then we have what? X squared minus beta x minus alpha x plus what? Alpha beta equals to 0. Now we can rearrange it having x squared minus alpha x minus beta x plus alpha beta. Now, it's still the same thing as saying x squared minus what? Minus into alpha plus beta x plus alpha beta. Check it out. By the time you expand it back, the result is still the same thing. Now, that's not the issue. Now we can say that let this be our what? Equation 1. Let it be our equation 1. If you remember very well, we have something like by what? By law of quadratic. By law of quadratic. When we were proving the completing the square method, we have it that ax squared plus bx plus c equals to 0. Now, whenever you have the quadratic equation, it should go like this. Now, we are having that, we can say that ax squared plus bx equals to minus c. Now we are dividing through, divide through by coefficient of what? Coefficient of x squared. That's ax squared divided by a plus b over ax equals to
Part 2.
plus b over ax equals to minus c over a. And this is taking care of this. Now, we proceed saying that we are having x squared plus b over ax as goes, then equals to minus c over a. Then what? Then what happens? Then we bring this back. Then we are having what? X squared plus b over ax plus c over a equals to 0. Then we say that let this one be our what? Our equation 2. Now, we now say that what? Equate 1 to what? 1 to 2. Now, how do we do that? Then we are having x squared minus alpha plus beta x plus alpha beta equals to x squared plus b over ax plus c over a. Then we are having x squared minus x squared. This comes like this, minus what? X plus alpha plus beta x plus alpha beta equals to what? B over ax plus c over a. Then this is gone. So we are having left minus alpha plus beta x plus alpha beta equals to b over ax plus c over a. Now when I say comparing what? Comparing the coefficients. The coefficient of what? Of x. Now we now have that what? Alpha plus beta x equals to what? B over ax. Then x cancel x. So we are left with alpha plus beta to be equals to minus b over a. I'm very much sure that majority of you are familiar with this equation. Now whenever you have sum of roots, our sum of roots is always minus b over a. Majority of you are familiar with that, but you don't know how they come about that. That is why I'm showing the derivative of how we come about that. Now, simply saying that what? Getting our product of roots. We now say that what? Comparing constant terms. Comparing constant terms. So what are the constant terms? Our constant terms are what? Alpha, beta equals to what? C over A. Now, you have heard about this. For those of you doing further maths and advanced maths, we have our sum of roots to be minus b over a, and we have the product of roots to be what? C over a. But now I will tell you that this equation here, it is the equation for what? For getting the quadratic equation. It's the formula for getting the quadratic equation. Like cases like you might be giving, maybe you might be given some roots. Okay, find the equation. So this is the formula we use to get cases like when you are given a root to find the equation that makes up the roots. So thank you and thank you. Don't forget to follow this page and share this video, like and comment. So we are going to be solving questions on this in our next video. God bless you.